Bismillah ar-Rahman ar-Rahim. First of all, if you don't mind, I will record the lectures, and I will talk about the procedure for this recording later. So, welcome to the Advanced Computer course. So this course builds on the introductory courses that you have studied possibly in the undergrad, like Network 1 and Network 2 for computer engineers. This course mainly covers the highest three layers: application layer, transport layer, and network layer. So we don't cover any issues related to data link layer and physical layer as part of this course. And the reason is that there are some other courses like wireless communication, ad hoc, and all other networking courses that cover these layers extensively. So in this course, we only cover the highest three layers. So also, of course, in Network 1 and Network 2, you have touched on these layers before, whether you studied at QU or elsewhere. And you will find that, although there is slight overlap, but you will see that we'll go, a little bit more in depth in this course in each of these layers, as you will see. So the textbook that we will go through is called the Kuros and Ross. There is the 7th edition. The 6th edition is more than enough, and I advise you to have this book as the main reference. You actually might need, especially if you are a PhD student and you want to study for comprehensive exams and stuff like that. It's many students, they select this particular course for later exams in PhD. So of course I'm going to be handing some papers. Some of them will be handed in a form of assignment that you have to, maybe some of you took some courses with me before, so they are familiar with the system. So I'm going to talk about the assessments. Part of it is actually to review some technical papers and provide some technical report to summarize the findings of this paper. And these papers are usually, recently published papers, which is part of this. CCNA 1 and CCNA 2 material is very much optional. You don't really need it. Yeah. They are very much secondary in this as a course reference. So of course we're going to be using Blackboard for all the course management. And if you try to access Blackboard now, you will see that I've added some material and also the list of seminars. So every week we're going to have seminars by the students. I'm going to talk about this. The main goal of the course is to understand and analyze contemporary transport, switching, routing, and network planning techniques. And in that, there are some course learning outcomes, including first, of course, the first one is to really refresh some introductions in your mind regarding Network 1 and Network 2. So here we're going to be talking about some basic concepts, terminology. Some of them are familiar to you studying in undergrad. Some of them are possibly new. So this course learning outcomes is going to cover all the basics and terminology that we will use throughout the course. The next course learning outcome is to design a reliable transport control protocol. Design and analyze means that you have complete understanding, not only as to be able to analyze, which means that you need to understand the algorithmic part of TCP, unlike what you have studied in Network 1 and Network 2. Here we're going to be covering the algorithmic aspect of TCP. So we're going to go through some algorithms that are used for example, congestion control, flow control for TCP, which possibly you did not study in the undergrad. Similarly, routing protocols, we're going to go through some dynamic routing protocols like RIP and EIGRP or something like this. Again, from an algorithmic standpoint, not from a protocol and header standpoint, like what you have studied in Network 1 and Network 2. So of course, here we are trying to push and prepare students to be able to do research, right? So here we're going to cover the algorithmic part of it. Simulating network switching and routing. This part is covering by the practical aspect, and you have assignments, and you have of course the project component. The course is project based. As you will see, the project is a major component as part of the course. And this is a slight change from the course offerings of previous years. So the project this year is going to be more project-based. So a practical part requires the fact that you have to familiarize yourself with some specific simulators, which are going to be required as part of the assignment, but also some simulators that you are possibly familiar with, like, for example, MATLAB, NS3, OpNet, things like that. Any other simulators that you are possibly familiar with, or you get yourself familiar with throughout the class. So you need to learn that in parallel, familiarize yourself with it, and possibly use it as part of the project. Okay? So in the assignments, maybe I will dictate a certain simulator, and I'll tell you, use that simulator. But in the project, you're going to have all the flexibility to use whatever simulator you want. Or you build your own simulator for that matter. I don't mind. Okay? I'm going to talk about the process of the project in a minute. And develop a network design project. So the project is going to be, I think, individual based on the number of students that we have. It's not that high. So sometimes we have more than 10, in which case I will have, each two will have a group to work on a project. But I think given the number in the class, possibly we'll end up with maybe 6 to 8 students. So it's fine that you will have your own project to work on. I'm gonna be talking about the process of the project in a minute as part of the assessments. Okay, so this is a bit stuff. It's not that important. These are the topics, and today we're going to be covering the introduction to networking. And again, we're going to agree on some terminology that some of which you will find you have not been introduced to before. And then we're going to go like network one. Here, the book is top-down approach. So unlike possibly CCNA1, which is bottom-up, so it starts from the physical layer first. It starts from the network access layer, physical layer and data link layer, and then it goes up. Here, this book is actually top-down. And these are different philosophies when it comes to covering any networking course. So here we're gonna go through the top-down approach, where we go through the application layer first, transport layer, and then transport layer is gonna take like 4 weeks or something, and then the routing. And then at the end, this is again added recently. Of course, I mean, we cannot miss the fact that, of course, there are certain recent trends like IoT, edge computing, and distributed AI, and all these things. So I thought we can just augment the material of the course with some of these recent trends, and we talk about them, and I'll get you familiar with some of the research that we are doing in these areas, and also other groups are doing. Okay? Feel free to interrupt me whenever you have any questions. Okay, so these are the topics, which are divided, of course, as I said, based on the highest 3 layers: application layer, transport layer, and routing. Okay, so the last or the most important part is the assessment. Is the assessment. Okay, so again, one thing that I have done this year clearly is the fact that I have actually removed the final. There is no requirement for the final because it's a project-based course. So I actually tweaked a little bit the course to make it project-based. I'm going to talk about the implication of this in terms of assessment. Okay, so the project is a major component, and actually it's slightly above 30%, as I will clarify in a minute. So the project is a major component, 30%, and obviously it has to be development based. So no one comes to me and say, okay, so I'm going to use, like, for example, packet tracer, or okay, don't try to get around this. If you are not really confident with development, then there's a problem here, because in the project you're going to have to demonstrate some development skills. Okay, there's a major development component in the project. So usually the way that I conduct the project is actually through phases. So so very soon you will actually in the next couple of days you should really get a notification from Blackboard, hopefully, because the notifications sometimes do not work that efficient. But if you check Blackboard, you will find a project description. In the project description, I'm gonna give you some description about how the project is gonna go, and usually there is a requirement for, like, in about 2 weeks from now, or maybe I make it, let's say by the second week of September or something, we're gonna have to submit a phase 1 of the project. This phase 1 is just a proposal. So this is actually a proposal. So in the proposal, you're gonna list in a high level the scope of the project that you want to work on, okay, and the list of deliverables and the objectives. It's just one page, okay. So these are just bullet points, very high level. For each of these phases, I have to say that for each of these phases, I'm gonna have to give you some feedback. If I don't give you feedback, you should really try to provoke me and ask for a feedback, because this is important for you to continue to the next phase. So in phase 1, it's going to be the proposal, high-level descriptions, list of objectives, some specific outcomes that you are expecting to have. Like, for example, I want to build a simulator, or I want to implement, like, for example, some AI on Raspberry Pi, or I'm going to implement like some security protocol with this description, things like that. Okay. So the feedback in this phase usually is that, the scope that you are specifying is trivial, and you have to write more details, or you provide more clarifications, or you want to build a spaceship and this is not realistic. So you need to be reasonable and try to scope it down or something like this. Okay. So once we agree on phase 1, I expect you to start working right away, although in many cases this doesn't happen, and the students, they delay it at the very last minute, and then you have a problem at the end. It's up to you. But once we agree on phase 1, I expect you to start working right away. So in phase 2, which usually the deadline for it is going to be, like, for example, in week 8 or something like this, or week 7. Okay. It's going to be the detailed design. Okay. In the detailed design, I expect you to have everything but the results. In the detailed design, you're going to have to provide the specifications for the networking scenarios that you want to work on. Okay. And you specify, of course, the tools, everything that you want to use. And you don't have to provide results, although I expect you to start working on the development, but there's no requirement for results as part of phase 2. Okay. Although if you have some results, if you have elementary results, you actually add it, so you have the chance for me to give you some feedback. Okay. So that's phase 2, and of course phase 3. In phase 3, this is the final phase. This is the final, and this is usually divided into 2 things. So you will have to provide a presentation, okay, and then after few days after that, maybe 3 days or something, you will submit everything related to the project, including the presentation, the report, and the implementation, the code. Any questions regarding this? And the final will be after the vacation or before? No final. Midterm. The project final phase. Yeah. It's gonna be after the vacation or before? No, before. Everything. Most probably it's gonna be before. most probably it's going to be before. Because according to the university, the only thing that we need to do after is the final, and we don't have final. So technically, we're going to be done pretty much with the course, with everything related to the course before the vacation. If there is any change to that, I'll let you know.
For development, is there specific requirements like do we have to know something related to programming language or
Any programming language that you are familiar with. So you have here in the project, you have full control. But again, to some extent, because you have to tell me exactly what you are doing. So you have to provide really some progress. I expect you even in the office hours. Let me talk about the office hours. In the office hours, you need to provide some progress. If you have any issues, you come to me. Sometimes they come to me to the office hour and they say, well, the scope that we agreed on, it's not feasible. I cannot do it. What do I do? Okay? So in that case, I would suggest to you another alternative. Okay? So we'll work it out. We will refine the scope, maybe modify it, change it completely. In some cases, I provide some initial code to the students to get them up to speed, things like that. So the more interaction you have, okay, and the more you provide or you report your progress, the more help you're gonna have. Okay? Because some students, they don't even report anything except for phase 1, phase 2, and they provide the writing, and that's it. Even when I provide the comments, there's no interaction, nothing. Okay, so I expect them to be familiar with what they are doing. So I expect you, when you deliver the presentation at the end, that everything will be perfect. So it's up to you. Because if it's not perfect at that time, well, you blame no one but yourself, because the grade is going to be proportional to that. So does that answer your questions? Okay. The midterm, well, technically, in that case, it's not a midterm, of course. It's technically a final. Reshaped, okay? So usually the midterm is going to be towards the end, okay, maybe the last week of the, and it's comprehensive, of course, because I have no other choice. But we will agree on if there is any one chapter or something that's removed, okay? But it's one exam, one written exam, that's it. ماشي؟ طيب, the assignments. The assignments, we're going to have 4 assignments. The assignments are divided into 2 categories. Possibly 1 or 2 assignments are going to be review papers. So I'm going to give you some papers, technical papers, and you will be asked very specific questions about these papers. What is the main contribution of this paper? And in that case, you're going to have to read the paper carefully and then use your own words to describe and answer the questions. You don't copy and paste from the paper right away, as is. You need to use your own understanding to try to articulate what you understand from the paper. Okay? So that's maybe 2 assignments. The other 2 assignments are going to be simulation based. So I'll give you some exercise, and I'll give you clear instructions on what simulator you use, what steps you're going to have to do, things like that. And this is, of course, to enhance and improve your hands-on skills using certain simulator. And this hopefully should help you with the project as well. Any questions? Okay. So before we had the midterm and the final, and 25-20, so in total 45. So I actually removed 10%. I made it 1 exam, and I distributed the 10% on. So regarding the seminar, okay, so we'll talk about the seminar. Students are required to do seminars. Starting next week, we're going to have some victims to try to provide the seminar. And the seminar, the way you actually format your seminar is that usually you have at least 2 papers, 2 technical papers, okay? And you try to describe these technical papers in the seminar, in the presentation. Okay? So you provide some introduction about the topic, and then you talk about the first paper, and then you talk about the second paper. The first paper, for each paper, you need to talk about the motivation, okay, the contribution, the solution, and the results. That's it. So you need to be brief on how you talk about each paper. Okay, so that should really give you some preparation and some experience on how you really read technical papers, how you summarize, articulate, and try to find actually also some in the conclusion. You should try to also you provide some critique for these papers. Okay, so what you think is not done in this paper that you think is important and it can add value to this paper. Okay. Any
Is there specific topics or?
possibly based on the number again, students may have to provide 2 seminars. The first seminar is going to be general, and you select whatever topic. Okay, and if you have a seminar next week, you can feel free to contact me, and I can provide some suggestions in terms of papers. But you have to give me some topic. You say, like, I want to give a seminar about security in networks, for example. You have to give me some guideline. Okay, then I can suggest some papers to you, or you can use some keywords on Google and try to find some papers and send them to me. Some students, they for example, they download like 5 papers related to a certain topic, 5, 6 papers, and then they send me the 5 papers and they say, okay, so I don't know which of these papers is really worth reading. Okay. So, well, if you are familiar with this process, then it doesn't take you more than a couple of minutes to detect that this paper is worth reading or not. So if you are not familiar with that, send the papers to me and I can select. I can tell you, okay, select these 2 papers, other papers are useless. Okay? Or I didn't find any papers related to that topic, but I'm interested to work on this topic, so can you suggest some papers? So I can help you and do a quick search, or maybe suggest some papers based on some recent publications that we have done as part of our group and send them back to you.
How long is your seminar?
Yeah, the seminar itself will be about 20 minutes, not more than that. Not more than that. Okay? So one seminar, the first seminar is going to be general, and you have the flexibility to select whatever topic, whether it's related to the project or not. The other seminar is going to be more targeted towards your project. So by that time, you will have a clear idea about what you have to work on in the project. And then in the second seminar, I expect you to also use it to provide some progress on what you are doing, or in details what you are doing as part of the project, and what you expect to have, things like that. And these are related papers. You still need to provide some review of technical papers. These are related papers to my work, and you can also criticize these papers and provide some solution overview and so on. But you can use it also to provide some progress about your project. Any clear? Any questions? Okay. So this is these are all the assessments. I think that's pretty much what I wanted to talk about as part of this. Yeah, that's pretty much it. So for me, actually, the syllabus is actually the contract between the instructor and the student. So by the end of this, we seal the contract, and this is recorded, so you can refer to it if you are in doubt about any of the assessments. So you go back to this recording and try to find your answers in the recording. Any questions? Everything is clear? Okay. So, oops. So we have like half an hour or something before Maghrib, so we can start the introduction. And of course, some people, they don't like to start in the first day. I like to start on the first day. And on one hand, like, this gives this sense of seriousness to the students. On the other hand, starting early allows you to have some break in the middle or towards the end, when the race is like, it's like too exhaustive. So you have some chance to maybe have some breaks and take a breath before you continue. So we're gonna have to go through like some introductory slides. So again, this is the textbook, and as I said, although the textbook is 7th edition, but 6th edition is more than enough. So you try to have a copy of this because it's a good reference. I did not provide introduction about myself. I'm a professor in the department since 2007, and currently I'm the coordinator of graduate studies, so you're gonna have to deal with me so many times. I actually finished my master and PhD from Canada in 2001 and 2006. And after this, I joined the department in 2007. Before that, I worked also in IBM in Canada for 10 years while I was doing the master and PhD. So I worked heavily on developing many applications and web-based applications and different software solutions for different vertical industries, whether it's for insurance, for airlines, for hospitals and healthcare systems. I worked on software development for years. I actually took different roles, starting from a small or a junior developer all the way to a technical manager, team lead, and things like that. Okay, and then I switched completely to academia after 2007. So the slides is the slides provided by the book, although I made some significant modifications to the slide. So whatever I talk about here is what you need to know for the course and what you need to know for the exam, for any type of assessment. If it's not here, you are not required to know anything about it, even if it's in the book or in the original slides of the book. Okay. As a goal for this chapter is basically to provide some basic concepts. And some of these basic concepts are important terminology that you may or you may not be familiar with from Network 1 and Network 2. Some of them are new, but you need to understand them now and agree on them for the rest of the course. Like what's internet, what's a protocol, of course, some of which you will find yourself, you're already familiar with them. Okay. What is the network edge versus network core? What are the end devices? Some terminology related to the network, like routing, switching, things like that. Very importantly, the performance matrix. For any kind of research, simulations, things like that, one of the most important things is that you have to really think about the metric where you have to evaluate the performance of this network. Whether you're gonna have to use the delay, and even delay, there's processing delay, there's propagation delay, so there are different types of delays that we have to familiarize ourselves with. Or definitely the throughput, bandwidth, things like that. We'll talk about the protocol layers, the layered model. Of course, we talked about that in Network 1. We'll talk about the service models and so on. So what is the internet? The internet, of course, is an interconnection of millions of subnetworks. Okay, millions of connected computing devices, they constitute the internet. The internet is actually divided into as we can see, into like edge networks. This we call this edge network. Edge network is what end devices, okay, use to connect to the actual core of the network. So basically, here these are end devices, right? These end devices, they constitute what we call edge network. Okay, and this edge network usually shares some network resources. Okay, so these are network resources, and this tower is what we call the access network, or the technology that I will use to access the core network or to access the internet. Okay, of course, from a geographical point of view, we call this, all of this, we call it a, in network one, we call it a local area network, right? So we call this a local area network from a geographical point of view, that these are devices that they have the same proximity and they are all connected to one router port. So the termination of any LAN is a router port. So this router port, once you see this router port, this means that this whole thing is one LAN. Okay? And the internet, of course, is an interconnection of all these LANs and WANs. Type. So the definition of the internet has different meanings based on whether we are talking about the hardware perspective or the network architecture perspective or the service level perspective. So from a nuts and bullets هنا, I mean this is the term that's used in the book. Nuts and bullets معناها from a hardware perspective, from a physical low level hardware perspective. النتورك عبارة عن إيه؟ عبارة عن we have end devices, okay, some routers and switches and cables. That's what constitutes the internet. Okay, so from a hardware perspective, you have the end systems, and you have the communication links. Okay, and you have routers and switches. From communication links, these could be, طبعا, as you are all familiar with, the cables can be either fiber optics, coaxial, or wireless. Okay? So these are the different types of the cables. Routers are for طبعا packet forwarding and to establish route end-to-end to maintain the traffic, as we will talk about later. But from a hardware perspective, the internet is just an interconnection of some end devices with some network devices and cables. That's it. Okay? طيب, what makes the internet very scalable is the actual architecture and the protocols. So from a physical view, and I mean here from an architecture standpoint, it's very important for the internet to be scalable. And معناها scalable. What do we mean by scalable? حد عارف? What do we mean by scalable? أيوة. برافو عليك. Yes, that's perfect. That's perfect explanation. So the scalable معناها إيه? You can add more devices, okay? And the existing devices can still work with the new devices with a good level with a good quality of service. Okay? And this is the most important thing in any systems. What makes Apple, what makes Google, is actually the scalability. You can have millions and billions of users, and all of them can work with good quality of service. That's what makes really good systems from bad systems. هي scalability. Okay? So what makes really the internet scalable is the hierarchical architecture. The fact that you have LANs and WANs, but also you have internet service providers اللي هم بنسميهم tier 1 و tier 2 tier 3. يعني we have end devices, and these end devices, they have to have network access through one of the access methods that we will talk about later. Okay? and they have to connect with what we call tier 3 service provider. As an example, we here at QU, we take the internet service from who? From QU. So QU is our tier 3 service provider. Okay? Type QU takes the internet access from who? From tier 2 service provider اللي هو زي ايه؟ أوريدو أو فودافون. Okay? Tier 2 service providers, as you can imagine, they have network infrastructure which is more sophisticated compared to tier 3 service providers. And of course, these tier 2 service providers, they usually get the network access from tier 1 service providers. Okay? So this tiered architecture is what we call hierarchical architecture, and that's what makes the scalability. That's what makes the internet really scalable. Okay? You have this hierarchical service provisioning. Okay? So the internet is loosely hierarchical. It's composed of LANs and WANs, but of course, the most important thing is that tiered architecture. Okay? The service provisioning is done as hierarchy or different levels. طيب. There is also from a security standpoint, there is also the concept of public internet versus private internet. The internet by default is public internet, which means that anyone can get access to the internet and can work as part of the internet, right? The private intranet is slightly different. There are two conditions for an intranet to be an intranet. What are these? First, هي not public بس يعني private indicates what? That there is some secure communication private that's not available to the public, right? Okay? But there is another condition for intranet اللي هيجيبه ده يبقى فاكر صح. An intranet is owned by certain organization. Okay? So an intranet is used for private secure communication, and it's owned by one organization. And as an example, مثلا لو بنتكلم على مثلا ايه the offices of Microsoft over the internet. يعني do you think that Microsoft they don't use the internet for communication? They do use the internet for communication. However, they cannot really afford the fact that they can communicate through the internet and everybody sees what they are communicating. Imagine like they are exchanging some excerpts of code, مثلا Windows code. It doesn't make any sense that everybody can listen to that. Of course, they have very, very high level of security in that case. So they have to use private intranet. And all the offices of Microsoft, regardless of the geographical location. So unlike بقى LANs and WANs, because LANs and WANs, they have geographical يعني significance. Okay? LAN معناها local area network. معناها geographically located in the same area. تمام كده؟ إنما the intranet, it does not have any significance in terms of geographical. يعني معناها إيه؟ The offices of Microsoft, they are distributed all over the world. They don't exist in one location, obviously. Okay? So there are different offices all over the world, and they can communicate securely between any of these offices, okay, in a private communication that's secure and nobody listens to them. ازاي بقى طبعا بيحصل الكلام ده in terms of what techniques, what technologies they are using. طبعا يعني if you study طبعا network security and these things, you will get familiar with the technologies that they use to have this. Or some of you used already VPN and IPsec protocols which are used for this. حد familiar with the IPsec or VPN? VPN طبعا everybody uses VPN. So VPN is one of the enabling technologies that makes this possible. Okay? Any questions so far?
The point of they are not placed in one location.
Yeah, the intranet, they are not necessarily in one location.
But how they connect to each other? Like, for example, for LAN, there is a router.
Right. Yeah. What I mean is that this device can communicate with this device through a very special communication channel This red channel goes over, when I say communication, logical communication, but this logical communication goes through the physical topology, as you can see. This red channel, okay, is very secure. So even this router cannot read the communication that's happening because it's encrypted. Again, and if you take other security courses, you'll be able to understand this better. But anyone who tries to hack or tries to listen to this communication, you can't, because it's encrypted and there's all types of security that's happening. But these two devices, these are geographically distributed. So they are not localized in any way. Okay? So if you have this device, and this device, and all have like some, so this red is a logical intranet that's laid over the physical topology of the internet. واضحة دي؟ It's a logical intranet, okay, that's laid over the physical architecture of the internet. Okay? معناها ايه logical intranet? Private communication, it's very secure. Nobody can hack or listen into the communication that's happening, right? Yet it uses the physical topology of the internet. Okay? واضحة دي ولا؟ Okay? So that's how we do it. Of course, there is the concept of extranet, but this is not very important. Extranet, the only difference between extranet and intranet, حد عارف؟ اللي ايه؟ لا هو يعني extranet is owned by multiple organizations. That's the only, so it's still private communication, secure and everything. But this is مثلا how Microsoft and Google, they communicate together. Do you think that they don't communicate? They do communicate طبعا. Okay? So if you have one red logical network like this and one blue مثلا logical network مثلا for Google, which is also distributed all over the world, the red one can talk to the blue one, okay, using the concept of extranet. Again, there is, in addition to the private communication that's happening separately, there is also some private communication that's happening between the two organizations. So extranet is owned by multiple organizations. So
how does the internet being hierarchical help in it being scaled?
Tani, how we?
How does the internet being hierarchical
Uh-huh.
help in it being scaled?
Yeah, that's a very good question. That's a very good question. So basically, طبعا, it's not to say that you can scale the number of users, to infinity without having to do any upgrades or any increasing the network resources and so on. But the tiered architecture helps in the scalability in the sense that each tier has to think in the premises that they have, in the network resources that they have, in terms of how many routers, how many switches and stuff like that, and then start to increase the number of users. If the number of users exceeds above certain limits, then and only then they ask for more resources from network 2 service provider or tier 2 service providers. Okay? And the same thing happens if tier 2 service providers, so the tiered architecture allows the upgrades to happen every very less frequent time. Okay? So the hierarchical architecture allows for each one to manage certain category of users, and then and only then ask for more resources whenever the number of users exceeds certain limits. Okay? So so they increase the network resources by increasing by the number of servers, routers, switches, and all and everything like that. So so they do actually perform these upgrades every now and then, and definitely this comes with the recent trends of مثلا increasing the services in terms of triple play and high definition videos and all of this. So that requires the fact that the network has to upgrade, and that's why we have the evolution of مثلا second generation or third generation اللي هو 3G, 4G, 5G and so on. Okay? So by scalability here, I don't mean that the number of users can increase to infinity without having to do anything to the network. That's not logical. Okay. And also, if the tiered architecture allows each one to optimize the protocols and technologies and the techniques in their plan. For example, مثلا the tier 2 service providers like Ooredoo, they can really upgrade their network resources without affecting the tier 2 or tier 3 service providers or tier 1 service providers. So they can upgrade. مثلا they can upgrade this tower from 4G to 5G, okay? And the tier 1 service provider is not affected, okay? So the upgrade can be localized and can enhance the quality of service without affecting any other parts of the network, okay? And that really contributes to the fact that the number of users can increase significantly, okay? So after maybe years and years and years, maybe the tier 1 service provider can provide also the same level of upgrade, again, without affecting tier 2 or tier 1 service providers. So the fact that you can provide local upgrades to increase the scalability of the network, that's what makes the scalability of the internet sustainable until today, okay? And of course, another طبعا concept which aligns with this is the layered architecture. Layered architecture itself allows you to also upgrade مثلا the network services in certain layer without affecting all the other layers. صح؟ مش احنا اتعلمنا كده في network 1? Okay, so this layered model also contributes to the scalability of the internet. ماشي؟ فطبعا احنا يعني I did not talk about protocols because I know you are all familiar with what protocol is. Protocol is the main controller for all the rules of communication طبعا. So before we communicate together, we need to have a protocol. Even when we talk to each other, we have to have a protocol. ماشي? So if I start to talk to you in Chinese, okay, you will not understand anything because you don't understand Chinese. Okay? So protocol is what facilitates really the communication to happen efficiently. That's also a good question. So the private communication, does that affect the limitations on the number of users? And the answer is no. I mean, you can have again private channels, whether a peer-to-peer private channel. We'll talk about this, peer-to-peer private channels, or in a form of client server or something like this, and that does not have anything to do with the number of users. So you can increase the number of users and still have private communication. There's no effect on that. طيب, the protocols themselves, if they can have two forms. A protocol that's well defined and well agreed upon internationally, we call it a standard. بالظبط, برافو عليك. So if a protocol is agreed upon internationally, we call it a standard. If a protocol is not agreed upon internationally, ده بقى we call it ايه بقى؟ عكس الستاندرد ايه؟ هتفكر؟ proprietary بنسميه. proprietary معناها ان هو is not agreed upon internationally. طبعا all of these are examples for protocols that are standard. يعني لما نتكلم على TCP, IP, HTTP, Ethernet, things like that. Actually, except for Skype. Skype is not a standard. Standard معناها it's agreed upon international. معناها it's publicly available for anyone. They know it. They know all the specifications for this protocol. So if you open the IETF website, IETF is the standard body which is responsible for standardizing or providing the protocol specifications for all the internet standards. Okay? So if you open that website, you can get to the specifications of TCP or IP or HTTP or Ethernet, any of these protocols. You can list it, you can read it, it's publicly available, all the specifications. So somebody can actually get this specification and they can implement TCP on any device. It's publicly available, okay? Which means it's agreed upon. So even, مثلا, for a very clear example, you can have one application on مثلا Linux, one application on Windows, they talk to each other, صح? Using TCP. Because TCP here is like TCP here, they are both compliant with the standard, they can communicate, there's no problem, صح? So any two devices, even if they are done by different vendors, they can talk to each other using a certain protocol as long as it's standard, okay? Skype is an exception. It's not agreed upon internationally, in which case we call it a proprietary. Proprietary معناها it's not agreed upon internationally. Another example which was not a standard, but it was recently agreed upon internationally, اللي هو بيسميه EIGRP. هندرسه ده شوية في الراوتنج later on. That's a Cisco it was a proprietary protocol which was done by Cisco, and Cisco طبعا in the past it was the only dominant networking vendor, and their products dominated all the internet and things like that. So EIGRP, even though it was not a standard, but it was 90% of all the network devices was using EIGRP. Although it's not a standard, it's not publicly available. But recently, Cisco, they actually provided the proof of request for comment, or RFC. They actually published the RFC for EIGRP on the IETF website, and it was released as a standard. ماشي؟ مفهوم الفرق؟ So these are يعني basic concepts that we need to have in mind. From a service standpoint, which means from application layer standpoint, ماشي? The internet, it provides different services and distributed applications like web, VoIP, voice over IP, email, games, e-commerce, file sharing, things like that. These services, they can have different features. They provide different features, like the application requires 100% reliability. Okay, by 100% reliability, what do I mean by this? 100% reliability, this means that when I send you something, you have to expect that I'm sending you something, and you have to reply, and the communication has to be guaranteed both ways. There is no tolerance for loss. When I send you something, you have to confirm that you have received it. When you send me something, I have to confirm that I received it. All the communication is reliable. ماشي? Many of these مثلا services, they require 100% reliability. But some, especially مثلا when it comes to video streaming, okay? So for video, even high definition video, does that require 100% reliability? No, it doesn't. Okay? So if there is some small loss in the video, your eye will not even tolerate, you will not even see it. Okay? So 100% reliability is not required in certain services, like, for example, video streaming. Okay? Another service is like DNS. You know DNS, domain name service, which is used for domain name service, which is used to map the IPs to URLs and things like that. So this does not require 100% reliability, and therefore DNS مثلا uses UDP. It doesn't use TCP, because TCP, as we will study later, TCP provides 100% reliability. Okay, so some of these services, if they require 100% reliability, chances are many of them you will find that they use TCP as a transport layer protocol. Okay. Some of them, they don't require 100% reliability, in which case they can use UDP or any other protocols. ماشي? So from a reliability standpoint, these services, they differ in terms of requirements of reliability. Oh, many, like file sharing, emails, all the web browsing except for video streaming. Okay, because file sharing, like imagine file sharing معناها إيه؟ Can you accommodate any loss if you are exchanging files? If you are sending like a zip file or something and there is only one packet loss, خلاص the file becomes corrupted, صح? So these services, they have to use TCP. There's no other way. ماشي? Best effort, of course, is what we mean by unreliable. Best effort, طبعا the most common example for best effort is IP. IP itself, so IP as a protocol is best effort. As we studied in Network 1, IP معناها ايه best effort؟ معناها if I want to send you something, I don't have to tell you that I'm sending you something. I just send it خلاص. But the cost or the implication is it may never reach you, صح? But we will try, but this is what we mean by best effort. We will try to deliver it, but if there is any problem to deliver it, خلاص, we'll drop the packet. Without even telling you, in many cases, without even telling you that the packet was lost. How do I know that the packet is lost even though you don't inform me that the packet was lost? Usually I wait for some time to receive something from you. Like مثلا, if I tell you something and you don't hear it, okay? So I wait for some time. If I don't see any acknowledgement from you, even like doing this or any other indication that you have heard me, then I assume that you did not hear me. Okay? That's what happens. So in best effort, if I send you something, first of all, I don't have to tell you, I don't expect you to expect that the packet is coming. I don't have to wait for you to expect anything. Okay? I send you, and then when you receive it, you should send me back some reply. If I don't receive the reply for a certain period of time, then I assume that you did not receive it. That's the only indication for me that you have received it or not. But the network itself does not provide any notification whether the packet was delivered or not. Does it? Okay. So that's what best effort means. There's no guarantees for reliability in any way. Okay? واضحة دي؟ Right. Right, exactly. Yeah, well, it depends on the protocol. Okay, if there is some level of, because sometimes there is some level of reliability. Okay, so in that case, if the timeout elapsed, okay, and you did not receive any acknowledgement, okay, then you send the packet again. In some cases, if reliability is not a requirement, I don't have to send it again. If I don't send it again, maybe I rely on other layers or other parts of the network to send it, things like that. We'll talk about these details later. ماشي؟ طيب, again, so a protocol, we have the protocol as a definition, we have the human protocols and we have the network protocols. And there is a lot of similarity between the two. So this is like an example of some conversation that happens between any two human beings, right? And that's exactly what happens in the network protocols. So human protocols is like we have to have a protocol before we can exchange any sentences, any conversation. Okay? So when I start my communication by saying Assalamu alaikum, you have to have some expectation based on that. First, I want to talk to you. Second, talk to you probably in Arabic, things like that. So we have to establish some rules before we start communication. If we cannot establish these rules, then the communication is not going to happen. Like, for example, if I talk to you in Chinese something and you do not understand it, then the communication is not going to start. It's not going to happen. Okay? So this is exactly what happens for network protocols. Machine, they all communicate and they have to establish, like, for example, TCP handshake. If you remember, in Network 1, we studied TCP handshake, right? So TCP handshake is the connection request that happens, that I send you some connection request, I want to talk to you, then you say, I accept you talking to me, and then you start communication, things like that, okay? So that's how the network protocols work. And these network protocols, they include some format, some order of messages, some specific header format, and things like that. We studied this extensively طبعا in Network 1. And we talked about the header format of each of these protocols, why we have this field here in this place, and so on. ماشي? So the protocol is the main controllers of the rules of communication. It governs all the rules of communication. ماشي؟ طيب. طيب, this is exactly the same example. So for human, you say hi, got the time, yes, I got the time is كذا, خلاص. So that's a very common conversation example. Similarly, if I send you TCP connection, then you send a response, then I start talking to you. It's the exact same thing, right? So before we talk, we have to agree on the messages that we send, the format of the messages, the version of the protocol, things like that. Sometimes we talk TCP, but then we have to exchange the version of TCP that we have to use for talking. So some devices, some end devices, they have different versions of the same protocol. So when I send you the request, I have to tell you that I'm using this particular version of the protocol. Okay? ماشي? Any questions? So what protocol means. Network edge, the edge, and we didn't talk about this in network one, we didn't touch it that frequently, but by network edge I mean the first entry point of the network, which is composed of end devices, and these end devices, they share some access method to get access to the internet or to the network. Okay, so this is called edge. ماشي كده؟ And this is called the access method. Okay? Other than this is what we call the core network. So this is in fact this infrastructure is what I mean by this is a core network. The core network is usually maintained by the service providers اللي هم tier 3, tier 2, tier 1 اللي احنا اتكلمنا عليه. Okay, clear? So the core network is maintained by the tier service providers, tier 3, tier 2, tier 8, tier 1. Okay? And devices are usually طبعا owned by users, by consumers, by us. ماشي? And each of these devices, they have to use certain access method. Depending on this access method, there are so many implications. Whether these end devices, whether they share the network resources or they have dedicated network resources. ماشي؟ يعني for example هنا مثلا all of them they use مثلا 5G tower. This is 5G tower. Okay, this 5G tower is shared between all the end devices. So this access method provides some level of sharing. And this sharing has to be controlled. If we are in a meeting, مثلا, if we are sitting in a meeting, we have the same floor. If all of us talk at the same time, it's going to be a big mess. So we have to have some way to share the floor of the meeting, okay, for each of us to speak at certain time and so on and so forth. That's why we studied SISMA and all the other access techniques. فاكرين؟ اللي هو SISMA اللي هو carrier sense multiple access for wireless مثلا. For those of you who are familiar with this. Are there some access methods that they do not provide sharing? Yes, there are some access methods that allows you to have dedicated line end to end. Okay, this dedicated line might be physical or logical. In fact, in our houses nowadays, alhamdulillah, we have great bounty. We have مثلا fiber to home مثلا. This fiber to home is almost dedicated. Okay, in the past we used to have what we call DSL. DSL provides dedicated physical end to end. Okay, so we don't share a tower like this. Okay. So depending on this access method, we may or may not have some level of sharing. طيب, So عرفنا ايه الedge network, الcore network, and the access methods. We'll talk about the access methods later in more details, and we'll talk about the different technologies. We'll talk in very much details. ماشي. طيب in terms of research بقى طبعا يعني in the past يعني maybe until maybe the 90s, late 90s, everybody was doing research in the core network. Starting from 2000, the research in the core network kind of يعني saturated, because all the research in the core network really relies on some routing techniques and switching techniques and so on. So these techniques, they have been saturated, and in many cases the core network is owned by service providers, so you require infrastructure to be able to do some research in this area. So the research kind of يعني stumbled a little bit, and it's saturated from 2000. So most of the research from 2000 until maybe recently, a couple of years ago, was actually in the edge. Okay? So most of the research, maybe 80% in the research was in the edge, all the shared methods, techniques, things like that. And of course, edge computing, which is a very major topic that we'll talk about in the end, started to really have great significance. And the reason for this is that it was promoted by طبعا Cisco to try to really يعني promote the need for distributed systems and networks and things like that. Because people stopped talking about network infrastructure and so on, so they promoted the concept of edge computing. So most of the research starting from 2000 has actually focused on edge networks, including communication and computing in the edge. Starting a couple of years ago, people are starting to go back to the core network because of thanks to the proliferation of what we call software-defined networks. So what happened is that all the network control techniques have been softwareized. Okay? They have been يعني implemented in the cloud. Of course, the concept of cloud computing is really يعني really promoted heavily. So one of the things is that the network control services have been really tried to be implemented in the cloud, and that created the paradigm of software-defined networks. So now all the network services are now softwareized. So, for example, I can have all the control techniques of the network done in the cloud. So these routers and switches are dumb. They don't have any intelligence. They don't do any dynamic routing protocols. They don't do all of this. Okay? So in that case, everything is done in the cloud. And that actually sort of revived the research in the core network once more, only a couple of years back. So we started to have مثلا frameworks like OpenFlow, like software-defined networks like virtual network functions, VNFs, and things like that, and network slicing, which is currently part of 5G and 5.5G and 6G. So now people are starting to do more and more research in the core network, but actually in that case, it's all softwareized. So that's يعني a small hint about how the research is focused now. Any questions? طيب, so the network edge, as we said, is focused on the end systems, and this can be defined in two categories: the client-server model and the peer-to-peer. I expect you to be familiar with the difference between client-server and peer-to-peer. Many students, by the way, they get into the trap of the fact that clients, they always download, and servers, they upload. And that's a big misconception. What is the definition of a client? A client is the one that always initiates the request or initiates the service, even if that service is to upload something. but the communication always starts and initiates from the client. A client may request to upload something to the server, but it's the one that always asks or always requests the service. Okay, so your browser requests service from the Google مثلا server to play a certain YouTube video. Okay, the client is always the one that requests or initiates the request. Okay, a client may request to upload something or download something. And I've seen this misconception for many students. ماشي? Once they see that the client uploads something, then they panic. So the main difference between the client and server and the peer-to-peer is that for client and server you have naturally many clients. It's many to one, basically. So this is client 1, client 2, client 3, client 4, and so on. All of them, they get the service or they request the service from one server. Okay? So it's many to one relationship. Whereas for peer-to-peer, there's no designated server in that case. The peers, they are logically connected in a form of like mesh. So anyone can communicate with anyone. Anyone can initiate the service from anyone. And anyone can upload or download anything to any other peer. ماشي? So there is no designated server in that case. ماشي? So in that case, the peer-to-peer is not many to one. It's actually many to many. Anyone can communicate to anyone. Okay? So what is the implication of this in terms of pros and cons? Of course, the client server constitutes maybe 90% of the internet. Just to be clear, okay? And why is this? Because of the fact that, of course, services nowadays, they have two major components. They have the actual content. There is a content that you want to exchange, and there is some kind of management and control. Management and control, like represented by an algorithm or some kind of intelligence. Okay? There's some management process that has to happen. Like for example, مثلا on WhatsApp. Okay? On WhatsApp, I communicate with someone, right? But in the back scene, there is like some management. I have to connect to the WhatsApp server. I have to identify myself, give my phone number. There is some kind of a management that have to happen in the back scene before I can communicate to anyone. Right? ماشي? So this management process is important. For client server, both the content and the management happens on the server. ماشي? طيب, what's the implication of this? This is much easier to manage because it's one location that manages everything. Everyone has to go through the server to have any kind of content, access to this content, right? So I can authenticate users easily. It's very secure because I can have my own access list. I can allow one user to gain access. I can, prevent any users from gaining access, things like that. Everything is maintained in one location, so it's easy to manage. Easy to manage and easy to secure. ماشي? طيب? So these are the pros. What are the cons? Single point of failure. برافو عليك. So if the server is down, all these clients, they cannot talk to each other. خلاص. They cannot have any service. Like for example, you connect to the bank and the bank server is down. خلاص. You're doomed. خلاص. You cannot have access to any service. خلاص. ماشي? So these are the pros and cons. Here on the other side, it's the other way around. It's actually the content itself is not centralized. The content is distributed. So you have content here, content here, content here. Okay? And these contents might be redundant. And you may have the same content in 2 or 3 different peers. Like for example, if you have used BitTorrent or any of the, I can download a movie مثلا, okay, from user 1 or user 2 or both at the same time. They have the same movie, so I can download it from anywhere, صح? Okay, so the content itself might be redundant. Okay, طيب, how the management is done بقى on peer-to-peer? How do we manage the access on peer-to-peer? ماشي? Theoretically on the internet, I'm not aware of a single service that performs management in a distributed way. ماشي؟ يعني BitTorrent مثلا, or eMule, or any Skype, WhatsApp, okay? These are all peer-to-peer services, صح? Peer-to-peer معناها إيه? It allows any 2 users to communicate together, صح? Even WhatsApp, we chat, any 2 people can chat, ماشي? But in terms of management, there is a server behind the scene that you don't see it. Everybody has to authenticate themselves and to have access through the server. Okay? So again, when we say peer-to-peer, it's distributed content, but management is still centralized. واضح النقطة ديت ولا مش واضحة؟ واضحة النقطة دي؟ So again, the peer-to-peer معناها إيه؟ Peer-to-peer معناها any peer can talk to any peer, صح? There is no designation of one being client and one being server. Anyone can initiate the communication to anyone, صح? مظبوط. However, in terms of management, who maintains the access? Okay, who maintains the security? That cannot happen in a totally distributed way. Okay, for peer-to-peer, you have to have servers. So if you connect to مثلا WhatsApp, if you connect to Skype, first you have to gain access through your user ID and password to authenticate your credentials against a server first. Once you do this step, then you can talk to anyone. Peer-to-peer, there's no problem. واضح? So that's the difference between, so peer-to-peer promotes distributed content, centralized management. Okay, it's not a single point of failure, obviously, because if one peer is down, I don't care. I can get the same movie from any other peer, because again, content is redundant. Okay, so it's not a single point of failure, obviously. ماشي? But here, security is much harder. Why? Why? Because if the content is centralized, the server can guarantee the authenticity of this content. ماشي? But if the content is distributed, I don't have, ماشي, I give you the access صح, but I don't have control which one you will get your content from. يعني you access مثلا through BitTorrent, خلاص, you gain access through a server. So now you can communicate with any peer. And then you decided to connect to someone in China and download files with virus. What do? خلاص, I don't have any control on the content. I have control only on the access and best to give you access. But once I give you access, I don't have control which one you download your files from. So you may potentially download files with virus. There is actually in BitTorrent, people stopped using it long time ago because of this. There's 90% possibility that whatever you download from BitTorrent has some form of a virus or Trojan. خلاص, it has become really infected with all kinds of viruses and Trojans. That's why people stopped using it long time ago. Right.
But I didn't download anything. I didn't access any link. Just only the website. It is just only the access, right? Why there is no management on this access?
هو الموضوع يعني there are different levels. What you're talking about is like there are certain websites these websites themselves, they are not really trusted. Sometimes you access some websites and they have some pop-ups, and there is some, of course, websites that use JavaScript. JavaScript has all types of issues when it comes to security because it's actually a code, and this code, by the way, you can view it, you can see it. Okay, if you say view source, you can see the code. So some people, when they see the code, you can really do whatever you want, and this can cause any types of attack. So that's why some browsers, they recommend disabling JavaScript. Okay, these JavaScript can actually open a pop-up window that accesses parts of your system, and they do all of this without you noticing. So that's why some people they actually disable JavaScript completely. So that's what happens. But here we're talking about file content sharing. So even with the level of file sharing, you may have get actually some infection with viruses and stuff like that, because we do not control and we do not trust the content on the peer-to-peer because of the fact that it's distributed. It's not owned by the server, because the server is owned by, obviously, an organization, a certain organization. So this organization can make sure that the content is trusted and so on and so forth. But here, the content is not owned by the organization, right? It's owned by the users.
Like
Like?
Google,
لا, what part of Google?
Google as a server. And
Google as a server, yes. Google as a server is owned by a certain organization, so they manage the content, they make sure that the content
but
is...
sometimes not all the content are secure.
In what form?
Some content they use different protocol, like for HTTP.
Yeah, but that doesn't mean they are not secure, because Google itself makes sure that their content is secure. Yeah, the Google, whatever content they own, they have to make sure that this is what makes Google Google. Because if the content itself is not secure, and people get infected with the fact that they just open Google مثلا websites, it's not going to be Google anymore. It's not going to be trusted. That's a big issue. But that's why مثلا in Google you don't see a service of Google that uses complete peer-to-peer with distributed content. ما فيش الكلام ده. There's no such thing. So vendors, they keep themselves away from using the distributed content in the form of peer-to-peer. Our BitTorrent actually, it was actually established to get around the fact that the content, they have copyrights. So they established themselves based on the model that I don't own the content, so I cannot really make sure that the copyrights are preserved because I don't own the content. All I do is just to open the floor for people to be able to communicate. Okay? So they tried to get around the copyrights of the content by not owning the content. But this business model was very successful for maybe a couple of decades. Okay? But later on, people started to use this concept to really harm each other. Okay? And that's why recently people stopped using BitTorrent. So even though I want to have access to many contents, but not to the extent to really harm my device or harm myself or something like this. So that's why, this is actually a problem for many of you who have kids or something like this. Sometimes they get to these websites and they harm مثلا the devices that they own or something like this. So that's a big issue, really. But when it comes to really well مثلا established or well-known organizations like Google or Apple, they cannot really afford the fact that some of their content is not secure. They have to really make sure that their content is really secure. Otherwise, people will not trust them. Okay? And that's why مثلا Google does not afford the fact that they use مثلا third-party services from any vendor or any service provider that, again, is not secure or not trusted. They have to make sure that all their services are secure and trusted. Any questions so far? So this is the difference between, so from a service standpoint, this is the what the internet architectures. ماشي طيب احنا خلاص هنقف هنا يعني. So we'll start talk about access networks, the different technologies for access networks next time, inshallah. ماشي. So this part you will see like many of you did not study these access methods at least يعني in details, unless maybe if you studied مثلا electrical engineering, digital communication, things like that, you may have come across some of these.